All right, start off, and before you can do complex numbers, you have to know imaginary numbers. So there is only one imaginary number. What's your imaginary number? I. So your imaginary number is I, which stands for square root of -1. Going through a couple things with that. So that's I. What is I squared? -1. Now, basically, that's all you need, but there's a little bit more to I that we can talk about. What would I cubed be? It's -I. Oh, this would be I squared times I, right? Well, what's I squared? -1. So it's -1 times I. So what's I to the fourth? 1. Because it's I squared times I squared, so it would be 1. So how about I to the fifth? It's I because you could write it like this. I to the fourth times I. I to the fourth is just 1, right? So I to the sixth would be I squared, which is, because you can take out an I to the fourth. So I to the seventh, -I. It'd be the same as I cubed, because you take out 4. And then I eighth would be 1. So what do you think? I didn't get any of the colors. Just a second. So what do you think I-20 would be? 1. Any multiple of 4 would be 1. One. Yeah, because what I could do is I could split this into I4 times I4 which I wouldn't even have to write out like that. I could write it like this. Why? I want to make it however is easiest for me. I can choose. Mathematically, I can choose however I want to make it. So I'm going to make it so it's like this. Okay, so how about I-29? What's that going to be? It's going to be I. Because I-28 is a multiple of 4, right? So I have I-28 times I. This disappears because it becomes 1. So I just get I. So how about I-50? -1. Because the closest number that's a multiple of 4 is 48. Which would leave me 2 left over. So this becomes 1. This becomes -1. So that gives me -1. Now, what that has to do with today, absolutely nothing. That's just fun. It is! Because for today, that's all we need.
This is like Inception.
No, that's not on any of your homework. Again, I just showed you that because that is a property of I. It's a cool thing to know. Doesn't help you because for everything that we're doing, the highest power you're going to have is I squared. But you can't really teach I without showing that because that's cool. So you should never have a power above I. I should never have an exponent on it. If you ever have an I with an exponent, get rid of it. Okay, so that's imaginary. So that's why there's only a single imaginary number. You should never have anything besides I, because it can always be turned into -1 if it has a power. It can be turned into -1, -I, or 1. All right, so complex numbers. Now, I don't really like the bubble diagram, but if you did the bubble diagram, you would have all your real numbers. You know, inside your real numbers, you have all the little bubbles. You have the rational numbers, the irrational numbers. Inside here, you have your integers, your whole numbers, all of those other little bubbles. Out here, you have your imaginary number, your one imaginary number. You put those together, that becomes complex numbers. Now, what you want your numbers to be is you want your numbers to be a complete set. Real numbers are not a complete set. In order to be complete, that means you should be able to do any mathematical function to it. No matter what mathematical function you do to it, your answer should be inside the set. Well, that's not true with real numbers because I can take a square root of a negative number and it's no longer inside the set. So reals are not a complete set. So in order to get a complete set, what we need is the complex numbers. Complex numbers is a complete set. A complex number looks like this. Every number you know of is a complex number. The number 4 is a complex number. Because it can be written like that. The number I is a complex number because it can be written like this. So every number you can think of is a complex number. It's a complete set. So what we're learning today is how to work with complex numbers. So whenever you're doing factoring, or not factoring, but completing the square, things like that, and you get answers that look like this, this is a complex number. You got a complex solution. But technically, all your answers are complex solutions. Again, we just don't write them out in complex format. Okay, you okay with that much? This part is considered the real part. This part is your imaginary part. Because all real numbers can be represented just by A. Your imaginary number can be just represented by BI. All right, so next part is learning how to do math with complex numbers. Okay, move it. If I can actually pull off a single sheet of paper. All right, math though is easy with these until you get to division. Division is harder. Okay, so let's do addition and subtraction. So let's see, let's take 4 plus 3i, and let's add 6 minus 5i. Okay, pretty much I is just a variable, just like x. So when we do any of this math, it's just like doing it with your polynomials. You just treat it like a variable. So all we're doing is combining like terms. So we take 4 plus 6 and 3 minus 5i. There's your solution. That's it. Subtraction works the same way. You just have to be careful when you subtract that you make sure you subtract both those numbers. You can't factor it. I mean, you could, but no. I mean, we want this to be a complex number. If I write it like this, that's not a complex number. All right, good with addition and subtraction?
Wait, why wouldn't that be complex? Is it given format?
Yeah, a complex number has to be A plus BI. If I have this, that involves multiplication. That's not just A plus BI. All right, so let's do multiplication. Okay, again, all this is, you just treat it like a variable. So all I have to do is distribute. So let's see, I would have 6 plus 2i minus 12i minus 4i squared. Now, the only change comes with, what is I squared? Negative 1. So whenever I go to simplify, I need to change that I to negative 1. Because again, whenever I do any kind of of math on this, my answer should come out as being a complex number. Okay, just to make sure we're not making a mistake on this, I want to do one. I want to do this one. Let's do one like that. I don't know why I put a parenthesis. Okay. Whenever you do that, you have to still distribute. Remember, this actually means this. It means you take that times itself. So that should be your answer. Yeah.
Does the real number always come first before,
It doesn't have to. That's just the way that it's written. It's someone someplace decided that the real number comes first. And it doesn't make it wrong if it doesn't. That's just the standard. While we're on multiplication, let's talk about this. Okay, if I multiply those together, you could add the 0i, you don't have to. Just like in a polynomial, whenever we have a 0 in front of an x, we don't necessarily write it. If we did that, that would mean that for the rest of the year, every time you write a 4, you'd have to write 4 plus 0i. We're not going to do that. Okay, this is actually very special. These are called complex conjugates. We're going to use them for division. Notice that whenever you take complex conjugates, now what makes a conjugate is one has a plus, one has a minus in front of the square root. We talked about that the other day. Now, we do have a square root here because remember, I is the square root of -1. What happens is you get rid of your imaginary part. That's very important for division. Okay, so let's move on to division. This is why in division, or in square roots, we teach you guys how to rationalize the denominator. You have your teachers who tell you, oh, there's no point in doing this. Just learn how to do it on your calculator. There is a point in doing this. Again, you guys get lied to. Because your calculator can't do this. It's not ignorance. It's not lied to. It's they don't understand. Your middle school teachers don't even have to have any sort of math background. Your middle school teachers are elementary teachers. Yeah. You're certified K through 8. Your middle school teachers have the same degree as your kindergarten teacher. Again, I'm not trying to. They do a great job for what they have. I could not handle middle schoolers.
I can't blame you for that. I would never do it.
I mean, I don't want to badmouth them because, I mean, they do a great job for what they have, but there has been a huge push to get Algebra 1 and geometry out of middle schools because they don't have the background to teach it.
What would it be?
Math 8, Math 6, Math 7. I know. I'm not in, don't take this the wrong way. I'm not in full support of that. There are different ways of doing it, and we shouldn't get into this conversation right now because we need to finish this. But there are other options other than having middle school teachers teaching it. Okay, in order to get rid of this, we need to multiply by the conjugate. So this is why you're supposed to learn how, whenever you're dealing with square roots, how to rationalize the denominator, because whenever you start dealing with complex numbers, this is a square root. So anytime you do division with complex numbers, you're rationalizing the denominator. What? Go ahead. You multiply by the conjugate of the denominator. So you multiply by the denominator with the opposite sign.
So like negative?
Yeah, so whatever this sign is, you just change it. Yeah, so whenever you multiply this, what you're going to get is you're going to get 25 minus 4i squared. So that would just be 29. So our square root is no longer in the denominator, so now we can actually divide. Now we have to deal with the mess on the top also. So let's see, that's 20. I didn't leave nearly enough room to do this. 20 plus 8i plus 15i plus 6i squared. So let's see, that's 14, because that becomes in minus 6, plus 23i. Okay, now, is this in standard form for a complex number? No. It has to look like a plus bi. Oops. Don't want an equal sign there. I want a plus sign. That's my complex number. So whenever I do this division, wherever I take this complex number, 4 plus 3i divided by 5 minus 2i, I get 14 29ths plus 23 29ths I. Okay, how about that one? Whenever you're rationalizing the denominator, you don't have a plus or minus sign on the bottom. All you have to do is multiply by the square root. The reason I couldn't do this on the top one is because if I just multiply by an I would create a 5i here, so that wouldn't do me any good, right? But on this one, if I multiply by an I, yeah, this just makes a 4i squared. Now my I squared would just disappear. So then I have 1/4 minus 3/4 I. So if you have something without the plus or minus sign, it's easier. When you rationalize that denominator, you can just multiply by I. Just like whenever you're rationalizing denominators with just a square root of 2 on the bottom, you can just multiply by square root of 2. Yeah. You can have a negative I. Having a negative I is just, that's negative 1i, that's fine. Okay, let's see, what else do we need to do? So we talked about multiplying, we talked about complex conjugates. Talked about that. Let me look through your homework, make sure I'm not missing anything there. So we did that, we did that, we did that. We did that. You can do that on your own. You can figure that one out. Okay, I think that's good. There's some extension problems, but I want you to try those on your own. The extension is like, now they're going to give you some quadratic formula problems with i's in them. Okay, so awesome. And a lot of you have couldn't already do that beforehand. No. Whenever you're doing quadratic formula, you'll just, you might end up with something like square root of negative 28. So you'll simplify that down to 2i square root of 7. So if I had here, let's say I was doing quadratic formula, I end up with something like 4 plus or minus square root of negative 28 over 2. Whenever I go to simplify that, that would be 4 plus or minus 2i square root of 7 over 2. Now I need to write that as a complex number. So that means I divide each of these by 2, right? So that'd be 2 plus or minus I radical 7. So that's, whenever you do quadratic formula, those are just going to be the types of answers you get. Okay, where am I? Page 167. 17 through 35 odd. 45 through 57 odd. And 65 through 69 odd.